right, guys, today we are going to go ahead and talk about the last change that we are going to do with our graphs and our transformations. So let's go ahead and kind of look at what we already have done. We've talked about how A, right here in the very front, changes our amplitude of the graph, which means how high up and how far down does our graph go. We've talked about how we have B, which is going to be the change in our period, which that value right there is always going to go ahead and tell us how long it's going to take for us to repeat our cycle. And we always use that as 2 pi over B to tell us what our period is. And then this K that is added at the end of either of those functions, that is our vertical shift. So it's going to shift my graph up or down, depending upon whether or not it's a positive number or a negative number. So what we're going to talk about today is in this part here where we've highlighted here is, well, what does B do? B as in boy. What that's going to do is that has our horizontal stretch, shrink, if you want to think about that. That's what it's doing with the graph. It's either making it go from this to something that is wider or something that is much more narrow. That would be that horizontal stretch or compression where it makes it from just the standard one to now it's been a much wider period or longer period or much shorter period. Okay. And that's what that horizontal shift is going to do. And if you recall here, one of the things I'm also saying is that it's a shift, right? Because that's exactly what that B value always does, is it's that horizontal shift, horizontal compression. And that's exactly what this is going to do. So what does B do? It's our horizontal stretch, compression. Okay, so it's going to do what to the period? It is going to either shorten or lengthen the period. Because if we've stretched our graph out, we've now made the period take a longer period before it's able to repeat. Okay, so now the last part of a sinusoidal function that we must discuss is the phase shift. So we got phase of the graph, or it's the horizontal translation. So if you look at what we have written up here, the only variable that we haven't addressed for any of the transformations for this would be the h value right here. So this x plus h within the function. So remember, if it's inside the function, it's the opposite of what you see, right? And so in the past, if it would be x minus 2, well, we know that means it's going to be x, and I go to the right 2. And that stays the same for this as well, okay? So in the standard form of a sinusoidal function, h is the value that shifts the graph right and left. To discuss the phase shift, you must have the interior of the function in vectored form. If you are asked to identify the phase shift, you will use the opposite of h, or negative h. Okay, so let's go ahead and look at what we have here. In this particular equation, I'm given sine of 2 times x plus pi over 4, all of that minus 6. So let's go ahead and identify what we have here. So out front, the number multiplied out front is my a. So what is my a here? Well, a here, if there's no number in front, it's going to be an implied imaginary 1, right? It's not 0, because if it was 0, that would cancel everything out, and I'd just be left with negative 6, because that's just something times 0 minus 6. So there, I've got my a is 1. All right. Now my b is right here. So there's b. So that's the 2. And then we have our h, which is right here, this pi over 4. And then we have this negative 6 here, which is my k. So these are my 4 variables that we have, and I can use those values to find all 4 of these things out. So first, to find the period. Now, period, what you do is it's always 2 pi over b, so 2 pi over b. Well, if I go ahead and look at right here, b, we indicated that is 2. So this is 2 pi over 2. So that just gets me pi. So the period of this function is pi. All right, phase shift. So phase shift is where I have whatever my h value is, and I'm just going to use the opposite. So h here, I have x plus pi over 4. This, whatever sign there is there, and the number is what h is. And so to find what my phase shift is, it's going to say it's negative pi over 4. Midline. Now, remember the midline is whatever your vertical shift is. That's whatever that k value is. So whatever's been added or subtracted at the very end, or even consequently, it could be rewritten as at the beginning, because this could have been negative 6 plus sine of 2 times x plus pi over 4. We could have done it that way where the negative 6 was in front. So again, it's whatever's added or subtracted outside of the function. And so this would be y equals negative 6. All right, and then now we also have our amplitude. So amplitude in this particular case is whatever my a value is. So it's whatever that leading coefficient is, and then I take the absolute value. So in this case, it's just a positive 1, so my amplitude is 1 because it's a positive 1. If I go to the next problem, the next one, I have 3 cosine times 6x minus pi plus 2. Now, look really carefully here and see if you can see a difference between how the equation is written here inside the parentheses and how this one is written here inside the parentheses. Okay? In this particular case, my b value here has been factored out. It's b times whatever this x plus pi over 4 is, right? Here, this x is not by itself. So in order for me to have an equation in a proper form and to be able to identify what my b is and what my h is correctly, I must factor out so that whatever I have for the x is completely by itself. So what I mean by that here is I'm going to take this and I'm going to go, I have 3 cosine, and this 6x minus pi, I'm going to pull out a 6. So that means I'm going to have that 6x right here. I'm going to divide by 6, but that also means I have to divide by 6 here. So let me fix this a little bit so it doesn't look so weird. So now I'm going to have 3 times cosine of 6 parentheses x minus pi over 6. And all of that plus 2. The difference between what I've done right here, like what I was given, and what I did right here is all I did was just evenly divide both x and negative pi by 6 so that I could pull that 6 out. Because if I redistribute that 6 into this, 6 times x would get me 6x, and 6 times negative pi over 6 would just get back negative pi. So these are equivalent statements, and the whole reason to do that is because now you can see the difference here, is that here, this negative pi over 6, that's that phase shift. It would be positive pi over 6. But if I did not pull out that 6, if I didn't factor it out, instead, I would have said that my phase shift was positive pi. I would have said that, I was moving to the right by pi. Because if I look right here, this just says negative pi. It's very, very different. I must factor it out. So it must be written, and that's why if you notice right here, this is written where that b is completely separate and the x is all by itself. Okay, so that got us our phase shift. Let's say the period of the graph, 2 pi over b, so 2 pi over b. b right here is this 6, so 2 pi over 6. Which is going to reduce down, and that will get me pi over 3. Midline. Midline, again, is whatever is added or subtracted at the end. Even if there's nothing added or subtracted, if there's nothing, then it's just 0. In this case, it's just y equals And then the last one that I've got here is for the amplitude. It's the absolute value of the a. So whatever number is multiplied by the trig function out front. And in this case, that's a positive 3. So my amplitude is 3. Okay, so now we're going to go ahead and graph these functions with some of these changes to them, okay? So one of the things that I like to go ahead and do when I set these up is I like to go ahead and kind of figure out what's going on with what I have. Do I need to go ahead and change anything? Immediate first step is to look, do I need to factor anything out before I do anything? In this case, the x is all by itself, so I don't have to worry about factoring. In fact, I can see that there's an a value of 1 that's not changing anything. There's this k value at the end that's being added that's just a plus 0. So really, I haven't moved my graph up or down. The only thing that is being changed right here is this phase shift. That's it. So what I'm going to go ahead and do is I'm going to set up a table just like we have been when we've been setting these up. So I'm going to do my x and my y. And I would go ahead and set this up just like what we're used to, where I'm going to do cosine and I do 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then my y values. And since we're doing cosine at 0 goes 1, then at pi over 2, we're 0, then pi would be -1, then 3 pi over 2 is 0, and 2 pi is back to 1. So we have those. Now, this negative pi over 3, what is it doing with my graph? Well, it is moving my graph to the right pi over 3. So it's taking, if I took whatever graph I have, and I mean here, let me just let me just draw that. If that's what I had for my graph, then instead, if I wanted to go ahead and do the exact same thing that pi over 3 is, instead I've just taken this graph and I'm going to shift it right pi over 3. Okay, that's all it's going to do. So that's what I need to kind of remember with what I'm doing here. Now, if I consider if all I'm doing is taking this overall graph right here and I'm going to shift it to the right 3, or I'm sorry, pi over 3, what coordinate point is going to change? Is that my x coordinate or my y coordinate? It's going to be my x coordinate because I'm going right and left, right? So that's what I need to do is I need to change the x coordinate. If you can recall, I've said it all year long and I will keep on saying it. If it is on the inside, so this highlighted part here, if it is on the inside, it will change your x values. It changes your graph horizontally. On the outside, the a and the k, that changes it vertically, so that changes the y values. So right here, what I'm going to go ahead and do is I'm going to go ahead and apply the change that is going to happen to our x values. And that is that my x values, we're going to go x plus pi over 3. Because my phase shift right here is whatever this is, and I'm going to add that to whatever I have here for my x values. Because we are shifting to the right pi over 3 from wherever we were. So I'd pull out my handy calculator and I go 0 plus pi over 3. Hope you don't need a calculator for that. That would get you pi over 3. But then next you have pi over 2 plus pi over 3. And that will get you 5 pi over 6. And then we'll do pi plus pi over 3. And that gets you 4 pi over 3. And then 3 pi over 2 plus pi over 3 will get you 11 pi over 6. And then 2 pi plus pi over 3 will get you 7 pi over 3. So in order to graph this, I will use these values that I just found as my new x-axis values and these values that I originally found as my y-axis. So I can go ahead and go 1, 2, 3, 5 little tick marks. So I got pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. And then a y value goes up to 1 and goes down to -1. And here's 0. All right, so let's graph this. So at pi over 3, we're up at 1. 5 pi over 6, we're at 0. 4 pi over 3, negative. 11 pi over 6, 0. 7 pi over 3, back up at 1. So that's what I've got. Now, if you notice, this is the first time that we're doing this. I have 5 things marked on my x-axis, including 0, 0 here. My graph is no longer starting on the y-axis as some sort of y-intercept. I'm no longer doing that because I've shifted my graph right. I shifted it right by pi over 3. So just keep in mind that this will not be drawn on that vertical. It will be off to the side. Okay, so midline of my graph. Midline of my graph, again, is always going to be whatever is being added after the equation. And in this case would be 0. So y equals 0. Amplitude, that's whatever my a value is, and take the absolute value. So a here is 1. Absolute value of 1 is still 1. Period. 2 pi over b. So 2 pi over, what's b here? Well, b is right here, and it's 1. So really, my period is just 2 pi. Phase shift, that's going to be that plus pi over 3, because it is the opposite of what you see there. So it's plus pi over 3. Okay, let's try another. What do we got? We got 2 more? Yeah. Okay. So right here, I've got -2 sine 1/3 x plus pi over 6. Okay, once again, this x is not by itself inside here. It has this 1/3 factored out. So I'm going to go -2 sine, and then I got 1/3 x plus, well, now pi over 6 divided by 1/3. Pi over 6 divided by 1/3. Keep, change, flip. So that would get me 3 pi over 6. So that reduces down to pi over 2. So that's what I end up getting right there. Okay, so let's go ahead and see what all we've got here. Okay, so with this, what we're going to go ahead and do now, and just kind of for the sake of it, I'm going to go ahead and just maybe make note over here. I'm going to say a is equal to -2. B is equal to 1/3. H is equal to pi over 2. And K is equal to 0. Just identifying my variables. That way I just have something already pulled out and I can look at it. If I remember, for example, that my midline is whatever D is with a Y in front of it. So, or I'm sorry, K. It's whatever K is right here. So that would just be Y equals 0. And period. Period is 2 pi over B. Well, here's B, 1/3. So 2 pi divided by 1/3. That's going to get me 6 pi. Keep, change, flip. Amplitude. Amplitude is whatever my A value is and take the absolute value. So here it's -2. The absolute value of -2 is just 2. Phase shift. It's always the opposite of whatever my H is. So H here is pi over 2, so it's negative pi over 2. See, I got all that without even graphing it. Now I can go ahead and start working on finding the values for the graph. Okay. Now, in order to do that, this one's going to be a little bit more complicated because this has more steps going on, because I do have an A value and it flips my graph. I do have a horizontal translation as well as a horizontal dilation. So I've got several things going on. So we're going to go ahead and start changing things up here. So I'm going to go ahead and create the original chart that we would use. And in this particular case, again, that's going to start at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And since this is sine, sine is going to go ahead and go 0, 1, 0, negative 1, 0. Okay, now we're going to start changing that. So when I consider what is this negative 2 going to do, well, that changes my y value. My y value is just going to be multiplied by negative 2. So I'm going to go ahead and just do that. I have negative 2y. So in other words, I have this 0 that's right there that I just need to go ahead and multiply it by negative 2. So 0 times negative 2 is still 0. How about this 1? 1 times negative 2. Well, that gets me negative 2. 0 times negative 2 is again back to 0, and negative 1 times negative 2 gets you a positive. Oh, not positive 1, positive 2. And then 0 times negative 2 is back to 0. Okay, so I can see that the highest up I'm going to go is 2. The furthest down I'm going to go is negative 2. So I've got that. Now, the next thing that I need to figure out is what am I going to do with everything that's on the inside of this? What is this 1/3 going to do? What is this pi over 2 going to do? So remember, one of the things that I've always said is whatever you see on the inside, you're going to see it do the opposite within your equation. What I mean by that is we are not going to be multiplying by 1/3. We're going to multiply by 3, okay? Just like I'm not going to add pi over 2, I'm going to subtract pi over 2. So I'm doing the opposite. Okay, so we can do this in 2 steps, and I think that might help some people. It's just to kind of not do it all at once. If you want to do it all at once, you're welcome to do that. But what I will go ahead and do is I will go ahead and actually make this a little bit more straight. I'll go ahead and do the first transformation, which would be addressing this 1/3, and that's where I take x and I multiply it by 3. So all of these x values I'm going to multiply by 3. So here, 0 times 3 is 0. Pi over 2 times 3 gets me 3 pi over 2. Pi times 3 is 3 pi. 3 pi over 2 times 3 would get me 9 pi over 2. And then 2 pi times 3 gets me 6 pi. So those would be some new x values, but I still have to do another transformation on them because that's just addressing just this 1/3. I still have to address what this pi over 2 is doing, which is where I've taken my entire graph and I've shifted every single output to the left pi over 2 because this is being added pi over 2. So I'm going to the left pi over 2. So now a last little column that I've got over here. I'm going to go, okay, so now I've got 3x, but that 3x, I'm going to subtract pi over 2 from it. Sorry, I've got, let me see if I can scoot over just a little bit. Nope. But here, nope, it's still not going to work. So I have 3x minus pi over 2. Let me clear that up just a little bit. 3x minus pi. Okay. So if I do 0, because remember this is 3x, which is this whole column, so it's saying take this column and just subtract pi over 2. So 0 minus pi over 2 gets me negative pi over 2. 3 pi over 2 minus pi over 2 just gets me pi. 3 pi minus pi over 2 gets me 5 pi over 2. 9 pi over 2 minus pi over 2 gets me just plain old 4 pi. And then 6 pi minus pi over 2, that's going to get me 11 pi over 2. So the thing that I'm going to graph will be these y values and these x values. So I'll go ahead and label the x-axis. In fact, I'm going to start over here because I have one of them's negative. So negative pi over 2. Pi 2, 4 pi, and 11 pi. Okay, so I've got those, and now I can go ahead and graph it. Oh, wait, I forgot. I gotta label my y-axis. My y-axis goes down to -2 and up 2. Okay, so at -pi/2, we're at 0. Pi, we're at -2. 5 pi/2 back to 0. 4 pi up to 2. And 11 pi/2 back to 0. So I got something like that. Okay? All right, last one. Right here, I got 4 cosine 2x minus pi/2 plus 2. I'm going to go ahead and suggest that you pause the video, try it on your own, and then see if you could get it correct. So, right here. Didn't mean to do that. I can go ahead, just like before, identify A is 4. So that tells me my amplitude, that's going to be 4. I can figure out that my B is going to be 2 because it's going to be what I'm going to factor out, and I'm going to go ahead and do that now. So I'm going to rewrite this. So it'd be 2x minus, well, what is pi/2? Negative pi/2, really, divided by 2. So keep, change, flip. So that would be negative pi/2 times 1/2. So that's just negative pi/4. So we have 2 times x minus pi/4 plus 2. And then we still have the 4 cosine in front. So that's our factored equation with the correct information in it. And that's where we could say our h is equal to pi/4. And our k is equal to 2. So with that information, I can also know that the midline of my graph is whatever my k is. So it's y equals 2. I know the period is 2 pi divided by b, so 2 pi/2. So that means that it's just pi. And then phase shift, that's what we're learning today, and that's going to be that pi/4 right there. It's the opposite because it's negative pi/4 in the equation, so here it's going to be positive pi/4. And so then the last thing that I need to do is I need to graph it, but in order to graph it, I have to apply all of these transformations. Now, if you notice, I have one for A, B, C, and, well, I keep saying C because that's what I'm using, or AP, H and K. So what we can go ahead and do is, just like we have been, let's create the table. So I've got X, Y, and we can go ahead and fill in the information. So this is cosine, and we're going to go 0, pi/2, pi, 3 pi/2, and 2 pi. And then cosine is 1, 0, -1, 0, 1. Okay, so we're going to go ahead and start with that. And then from there, we can go ahead and figure out what all the transformations are going to be. So remember, with this, we have both the 4 out front and the 2 out back. The A and the K change the graph vertically. This 2 is going to shift me up 2. This 4 is going to stretch the graph by a factor of 4, so it's going to get bigger. And it's going to do that vertically. So that's going to change all of our y values. So we can go ahead, set this up, and do it this way. And I'll tell you right now, you can do this 2 ways. I can sit here and I can do this and I can go, okay, so now I'm going to do 4y. And then what I would do here is whatever I get here, I'd add 2. Or, hear me out, you just do 4y plus 2 for the whole thing, okay? Because that's what you're going to end up doing. So here, I'm going to take that y, that 1, multiply it by 4, and add 2. That gets me 6. 4 times 0 is 0. 0 plus 2 is 2. Negative 1 times 4 is negative 4. Negative 4 plus 2 is negative 2. 0 times 4 is 0. Plus 2 is 2. And then 1 times 4 is 4. Plus 2 is 6. So I've got these values. Now I just need to label my x and y axis and plot the points. All right, so I'm gonna go. Oh, I'm not done. I got ahead of myself. Sorry, I just did the y values. We also need to do the x values. Let's keep in mind with the x values that we were looking at here, we're going to end up doing 1/2 times x because of this 2 right here. The 2 out in front, remember everything that I have on the inside is it's going to be the opposite of what you see. So because I see it's being multiplied by 2, what I could also say is that it's going to be a horizontal compression. It's going to make it smaller. I'm not multiplying by 2, I multiply by 1/2. And so that's exactly what we're going to do here. So I have 1/2 x. And so when I start doing that, I'm going to go 0 times 1/2. Well, 0 times 1/2 is still 0. What would be pi over 2 times 1/2? Well, pi over 2 times 1/2 is going to get me pi over 2. I'm sorry, pi over 4. I looked in the wrong spot of my brain here. And then pi. When I multiply that by 1/2, that's going to get me pi over 2. 3 pi over 2 times 1/2 is going to get me 3 pi over 4. And then 2 pi times 1/2 is going to get me pi. Okay, so that gets me just this issue here with the 2 within, but now I need to figure out what is this negative pi over 4 going to do. Well, I have to remember that that negative pi over 4 is the opposite of, again, what I would expect. And so I'm going to add pi over 4 to this 1/2 x. So I'm going to say whatever I had for 1/2 of x, I'm going to add pi over 4 to it. So in this case, 1/2 of x was 0. So I'm going to go 0 plus pi over 4. Well, that gets me pi over 4. Next one, pi over 4 plus pi over 4. That gets me pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4 is just pi. And pi plus pi over 4 is going to get me 5 pi over 4. So that gets me all of the x values and the y values in order to graph my function. So there's my x's and there's my y's. So let's go ahead and label the x-axis. This is pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. And then now I can see that my y-axis is going to go up to 6 and down to -2. So I've got -2 here. That would be 2, that would be 4, and that would be 6. Trying to kind of evenly space it a little bit. Okay, so now let's go ahead and graph that. So at pi over 4, we're up at 6. Pi over 2, we're at 2. 3 pi over 4, -2. Pi, we're up at 2. And 5 pi over 4 up at 6. So we got a graph somewhat like that. Okay. All right, so we have discussed amplitude, phase shift, period, and vertical shift over the last couple days. This should get you through everything. I will also just remind you that I did find a couple videos going through the homeworks for you guys, so I posted those, so be sure and check those out as well. Let me know if you have any questions.